this video, we're going to be converting recurring decimals into fractions. This is a small topic in the number part of your course that frequently comes up in exams. Once again, before we get started, make sure you check out mathsquared.org for further resources and to become part of the Mathsquared community. Let's get started. Which of these do you think is the nicest? 0.242424 or 0.24 recurring, or 8/33. Now, when I say nicest, I'm not referring to their value, as these are going to be the same. Which would be a cleaner way to write the number? Well, you might have guessed it. 8/33 is the nicest way to write the number, and this is because 0.24 recurring goes on forever and ever and ever. Well, in this lesson, I'm going to show a method to convert between a recurring decimal and a fraction. Let's start on this example here. We've been asked to write 0.18 recurring as a fraction. So what does 0.18 recurring actually mean? Well, 0.18 recurring is just 0.1888 and so on and so on. And what we're going to do is we're going to call this x. What would happen if we times x by 10? Well, as we know from place value, we'd be shifting all of those digits over the decimal point by 1. This gives us 1.8 recurring. Now what would happen if we times x by 100? This is exactly the same as before. We're going to shift everything over that decimal point to give us 18.8 recurring. You might notice that everything past these decimal points here is exactly the same. And this is the trick. If we take 10x away from 100x, we're going to be left with 90x. If we take the 1.8 recurring away from the 18.8 recurring, we're going to cancel out that 0.8 recurring on both, and we'll be left with 17. And now we're left with an algebra problem. We have 90x equal to 17. We can divide both sides by 90, and we're left with our final answer. We have that x is equal to the fraction 17 over 90. Of course, we remember that we started with x equal to 0.18 recurring. Therefore, we have stated that 0.18 recurring is equal to the fraction 17 over 90. We have successfully converted a recurring decimal into a fraction. Let's do a slightly harder example. Here we have 0.67 recurring, and we're required to convert it into a fraction. Now, notice the two dots above the 6 and the 7. What does this actually mean? Well, all this means is if we wrote this out fully, we would have 0.67676767, and so on and so on. Once again, we're going to set x equal to this 0.67 recurring, and then just as we did in the last example, we're going to times it by 10. This is going to shift all of those digits over the decimal point by one place. Notice that all of the digits after the decimal point are not the same, so we can't really use them at this point. We can try timesing x by 100 though. This will have the same effect as before. We're going to shift all of those digits past that decimal point by one more place. And now you can see all of those digits past that decimal point are the same. We're going to use that same trick again. We're going to take the x away from the 100x, and we're going to take the 0.67 recurring away from the 67.67 recurring. You might notice that all of the decimals are going to cancel out with each other to leave us with the algebraic expression 99x equals 67. Now we can divide both sides by 99 to get that x equals 67 over 99. We remember that we started with x equal to 0.67 recurring, so we have that 0.67 recurring equals the fraction 67 divided by 99. Let's look at a much more complicated example here. Now just to note, this isn't likely something that will come up in your exam. The reason I'm showing you this example here is to illustrate that this method works for any recurring decimal. So in this question, we're required to convert 0.289431 recurring into a fraction. Just in the usual manner, we can set this equal to x. What can we times x by to shift the first 6 digits of this decimal over to the other side of the decimal point? Well, as there are 6 digits here, we would times it by 1 followed by 6 zeros, or 1 million. So of course this would have the effect of shifting those 6 digits closest to the decimal point over to the other side of the decimal point. And finally, using that little trick that we've been using so far, we can take one away from the other to cancel out that recurring decimal. So 1 million x minus 1x will be 999,999x, and the 289431 minus 0 is just itself. And finally, we're left with this expression here. We can divide both sides by 999,999 to get x as a fraction, and then we can divide top and bottom by 9 to simplify this. Of course, we started by defining x as 0.289431 recurring, so we can finish by stating this. That brings us to the end of this lesson on recurring decimals to fractions. If you have any questions, don't hesitate to leave a comment below, like and subscribe, and I'll see you in the next video. Thank you, bye bye.